I thought it was about time I showed the old HXL actually making something for a change. This is going to be a small check valve. There's a piece of 5mm diameter 6L4V titanium, and that's been held in an ER25, I think, collet chuck in a HSK 63 clamping unit, which I made this faceplate up to go onto the A25 spindle nose of the lathe. The beauty of that is I've also got the same setup over here on the mill, so I can transfer work without taking it out of the collet straight over between the mill and then back to the lathe again, whatever. Seems to be working quite well, so we've got some cross drilling to do. This is the flight deck running LinuxCNC control setup that I made a couple of years ago. General tip of a workshop. It's due for the Christmas tidy up. Got a microscope on the lathe set up here, so you can actually see what's going on live on the monitor up there. So we'll hit play. See what happens. Just a roughing pass. It's a CCGT insert 12 with a 0.2 corner red. Nice and sharp, seems to work very well on titanium. And its finishing pass. Tool changed now onto a 0.5mm grooving tool. I'd normally have a bit of cutting oil on this, but you wouldn't be able to see what's going on. So that's actually the back chamfer of the thread. That's an O-ring groove, 200 micron step, and then there's a little channel which is cutting now. Fantastic insert. And then that's another 1/2 mil O-ring groove. A couple of holes to drill, back in a sec. Similar situation here, got a HSK 32 set up for drills and the like. Smaller than the HSK 63, obviously. Hold on. A 1 mil drill. Pipe drill into a depth of about 4mm, I think. spot of cutting oil on there. Okay, another manual tool change to a 600 micron drill. Bear with me. .600 micron carbide PCB drill. Going into a depth of about 6mm when it actually starts pecking at the bottom of the 4mm hole. Okay, that's nearly done. Right, what I'm going to do now is remove the entire collet chuck, which is quite difficult one-handed. Well, that is your HXL 63 ER25 tool holder, which we'll take across to said same clamping unit on the mill, which I might not be able to do single-handed. Hold on, yep. Okay, so set up with a 1mm again PCB drill carbide on an 1/8 shank. Mills all set up ready to go. That's a new, I say new, MQL system that I knocked up with the MQL nozzle and its cutting oil tank. Anyway, I digress. So this is all set up, so no centre drilling, no flats, just straight in on the top of the radius, which it seems quite happy with. It's the housing for the eye bag spindle, auto tool change, no tool at the moment, just a blanking plug in there. Chiller unit for said spindle with a lush up with a valve scenario at the moment, which needs mounting. Very pleased with the 4th axis, seems to be working very well. Now I've got Renishaw wireless probes for the SK40 main deckled spindle, and then a baby for the HSK32 and the high-speed spindle, and we're done cross drilling. So now a question of removing from the clamping unit on the mill, bringing it back to the clamping unit on the lathe, and now you can see our cross hole, which needs a bit of cleaning up. Minor deburr, so I'll get that done. I'll be back in a sec. Okay, what I've done here is I've deburred the outer of the hole, but what I've done is I've also taken a 600 micron drill back in to remove the burr that the cross drilling would have put onto the 600 micron hole. So just back that out manually, and next off to insert the internal parts and the welder. Before going to the welder, what I've got is a syringe with some IPA, alcohol, whatever, just to give this a bit of a flush through. And a blow out. Remove any residual grease, swarf, whatever. Right, now I can have a look inside it under the microscope, see if it's clean, and then put some parts in and think about welding it. Okay, to give an idea of the scale of what's going on inside of this thing, I've put a few of the internal parts in this tray under the microscope with a matchstick to kind of give an idea of the scale of things. So you've got a spring which is about 1.5 mil, 1.5 mil diameter. The balls are grade 10 stainless. The O-rings are 1.3 OD, 350 micron cross section. The rough looking turned bits there, that's the parted side, along with a bit of swarf, are the caps that will go on to the end. They'll get welded on to the end of the actual body. That's the actual valve side there, which is more the critical face of things, although the only thing that face will come into contact with in theory will be the O-ring. But I'm going to put a ball, an O-ring and a spring inside the body, and then I'm going to insert that end cap, and then I'm going to TIG weld that end cap onto the body, and then bring it all back to the lathe and finish it and thread it with a bit of luck. Okay, here's a brief shot of the internal parts assembled. You probably won't make out much of that, but you're looking at the O-ring in the foreground sitting on top of the 1.5 mil stainless ball which is on the spring, and there's a slight amount of protrusion of the O-ring and the ball, which will get compressed when I put the end cap in, which is a slight interference fit in that bore. So I'll put that in a minute. Right, end cap's in. It's all at this stage very nasty. So now it's off to the welder. Okay, this is a Lampert PUKU4 TIG welder. Fantastic bit of kit. That's an empty bottle of Peroni, which I shall have to do something about shortly. If you're wondering about one of these, don't hesitate, because you'll find yourself doing completely impossible things like this. So unfortunately I can't show you what I'm doing under the microscope, but I'm going to basically TIG round the end of that, and then we'll see what we've got back in the lathe in a second. Okay, back to the lathe, welding completed. So So that little flange on the end has become part of the main body. I'm not worried about the hole or anything else because we've got now a finishing tool path and a thread to cut on the end of the part. So we'll instigate that and we'll see what we're left with. Okay, so all being well, we'll run the final tool path, which will face, chamfer and clean up the end of the valve and then put an M3 thread on the end. So we'll see what happens. This is quite a gentle tool path because we're working right on the end. So now we can see our 600 micron holes emerged, and we're effectively dealing with one solid part. This is a bit of LinuxCNC threading. I'm just going to put a tiny dob of cutting fluid on there. This is laborious, so I'll pause it and come back to it. There's numerous passes because you can actually see there's deflection of the part as it springs away from the tool. So I think there's about 10 spring passes at the end of the tool path. Back in a minute. Thread done. Okay, it's back to the matchstick to give a, on my finger, to give a kind of an idea of scale. All it remains now really is to part it. Then we're back to the mill for the hexagonal broaching of 1.5mm hex. Quick view of the end before I part it. Okay, parting off. So that's a 0.5mm insert. And I'm not going to go all the way because it's going to fall. Oh, I'm going to have to stop filming because if I go all the way I'm going to lose it, so I need to hold on to it. Bear with me. Okay, all I've done here is just drill the relief hole for the 1.5mm broach and put a small chamfer on the end of the valve, ready to go over for broaching. Just loose fit in the where are we? We're here. So a few more to do and then we'll go to broaching. A quick probe of the 5C collet block, find the centre of that before we start broaching. Well, this is the broaching head, which is in a hydraulic 20mm shaft, so it's in a 20mm hydraulic tool holder, and it's sitting on the top of the valve with a bit of cutting oil ready to broach. And I've got it sat at the top of the part with Z set to 0 and 200 RPM, so it should stay where it is, and then I can drop it down manually. That's a millimetre going down, 1.5 millimetres. And 2 millimetres. So we'll go and see what we've got. So post broaching then, we've got a nice hexagonal form. We've got a burr at the bottom of it, which there should be, so we're going to now return them to the lathe, take the burr out of the bottom and take the last ½ mil of excess, which was an allowance on that face, which is at the moment 1.5 mil. Needs to be reduced down to 1 millimetre.